Today we're going to be studying similar solids. So, similar solids have exactly the same shape but not the same size. Two solids are similar if the ratio of their corresponding linear measurements are equal. When we talk about linear measurements, we're talking about length, width, height, radius, circumference, and perimeter. So when we talk about that, just think of centimeters, meters, feet. So we're not talking about feet squared, meters squared, centimeters squared. Linear measurements do not have a power to it. So let's start with number one. We're going to figure out if the solids are similar or not. So we talked about it, that it needs to have the same scale factor. So we're going to do big solid over small solid. So here's our big solid, here's a small solid. Well, here is the length for the big solid over the length for the small solid is equal to, here's the height of the big solid, height of the small solid. So 20 over 5 reduces to 4. 12 over 3 reduces to 4. And the width 8 over the width 2 reduces to 4. So the ratio is 4 to 1. 4 over 1 or 4 to 1. Let's take a look at number 3. Be careful with these shapes because even though one is laying down and one is standing upright, you still have to compare big to small, radius height to radius height, even if it's laying down. So let's look at the big one. The radius height here is 24, but the radius is 12. So we put 12 at the top. On a small figure, the radius is going to be 10, so we put 10 at the bottom. Height, remember height connects the bases. So the base at the bottom is a circle, the base at the top is a circle, it's connected by 30, so that's 30. Radius, height here, height is going to connect the bases, so the height here is 25. When we simplify it, we get 6 to 5. So you're going to do number 2, pause and do number 2. Okay, we're going to talk about comparing volume and surface area. So when we talk about comparing volume and surface area, if two solids are similar with a scale factor of A to B, which is what we just checked out in the previous slides, height to height, radius to radius, circumference to circumference. So if we find out that the scale factor is A to B, then the volume and surface area ratios are as followed. Surface area is going to be A to the second power to B to the second power, A to the third power, B to the third power. So anytime we see volume, think third power. Anytime we see area, think second power. So here we go. Identify the scale factors for each solid. So I'm going to go ahead and write it out. A to B, A squared to B squared, A cubed to B cubed. Okay. Well, let's figure out what the scale factor is first. Over here, this is 14 to 7. So 14 over 7. 10 over 5 and 3 over 6 all give me 2 to 1. So my scale factor is 2 to 1, which is what we have right here. So I'm going to write it here in red, 2 to 1. So my area is going to be 2 squared to 1 squared. So that's going to be 4 to 1. So I'm going to come over here and write it. My volume is going to be 2 to the third power, 1 to the third power. So that's going to be 2 times 2 is 4, times 2 is 8. So this is going to be 8 to 1. So this is what you do when comparing similar solids. Okay, so let's take a look at this one. We have similar solids, but they don't tell us what one side is. They're telling us what the surface area is. So if they're telling us what the surface area is, let's go ahead and put that in. And always simplify. If they don't simplify it, you have to simplify it. So my surface area of the first figure is 25 to the second figure, which is 4. Now I need to go up here. So when you do that, you are going to take the square root. You get smaller, you're going to take the square root. So we take the square root of 25 and we take the square root of 4. And so that would make our scale factor 5 to 2. Take the square root of 25 and the square root of 4, 5 to 2. So then my scale factor is 5 to 2. And then if I want to go to my volume, 5 cubed to 2 cubed, which gives me 125 to 8. Why do I have a star here? This is my home base. No matter what they give me, first step is always go back to the scale factor. And we will demonstrate that. Okay, so let's take a look at number 7. So for number 7, what am I given? I'm given volume. And the volume is 162 to 384. So you can put that in your calculator and hit math, enter, and it's going to simplify to 27 to 64. Remember we said that your scale factor is your home base? So we're going to get back to the scale factor. There's a button on your calculator. So the first thing I want you to do is I want you to hit 27 on your calculator. And then I want you to go to the math. Oops, no. What I want you to do is I want you to hit math on the calculator. You're going to see a cube root button. It's going to look like this. Pull it up and then put 27 under it. So when you do that, you're going to get 3 back to your home base. You're going to do the same thing with 64. Hit math, go to the cube root button. Cube root of 64 is 4. So now, home base, scale factor, let me go ahead and write that in, 3 to 4. To go to the ratio of my surface area, I meant to put a 4 there. Let me see if I can erase it. Barely. All right, so we're going to put a 4 here. And then once we put a 4 in here, we're going to square it. And so we get 9 to 16. There we go. Alrighty. So let's take a look at this one. What are we given? We are given surface area. And so we start here at surface area 960 to 375. If I put this in my calculator and hit math, enter, it's going to simplify for me, and it's going to simplify down to 64 to 25. So if I take the square root of 64, I get 8, and the square root of 25, I get 5. So now what I need to do, I need to take the 8 to the third power, and you could do 8 caret key, which is above the division key, 3, and you'll get 512. And 5 to the third power, you'll get 125. All right, so let's fill it in. 8 to 5, 512 to 125. Similar solids. All right, taking a look at this one. We talked about this already. We said that when you're given surface area volume, always go back to your home base, which is your scale factor A to B. We always want to do that first. So let's read through this question. Solid A is similar to solid B. The ratio of the height. Okay, so they're giving us height. So height of A to height of B is 7.3. So the question is, where do we put this in our little table? Well, yes, it goes here because it's height. That's one of our linear measurements. Now it says, find the ratio of the volume of solid A to solid B. So we are dealing with volume. So it's going to be third power, and voila, we get 343. to 27. Okay, so here we go. When we look at this problem, it says cone A is similar to cone B. The ratio of the surface area. So surface area of A to surface area of B is 16 dot dot 1. Where does that go on our little chart? Surface area goes here, 16 to 1. Find the ratio of the radius of the cone. So the question is, does this go to our scale factor or does it go to volume? Okay, well, it goes down to scale factor. It is a linear measurement. So we are going to take the square root of 16 dot dot, the square root of 1, and we get 4 to 1. So the ratio of cone A to cone B is 4 to 1. We didn't do volume because they didn't ask us anything about volume. Alrighty. So we're going to do a recall. Scale factor is A to B. Surface area is A squared to B squared. Volume is A to the third power, B to the third power. Always, always, always simplify your ratio. You can go to your calculator and put it in and do math and to enter. If given the surface area of the volume, always go back to your home base, which is the scale factor. Okay, our next couple of problems, we're going to do problem number 1. You got to read these questions carefully. The cones are similar. What is the ratio of the surface area to the larger cone? What is the ratio of the surface area of the larger cone to the surface area of the smaller cone? Well, this here is a side, so that's going to be 28 over 8, and so we're going to write that here, 28 dot dot 8. And then what we're going to do is we're going to simplify that, math into enter, and we get that this goes to 7 to 2. Let's put that in red. So this is 7 dot dot 2. Okay, they want the surface area, so we're going to take 7 square it, 2 square it, and we get 49 to 4. That's the ratio of the larger surface area to the smaller surface area. Now let's put it all together. Here we go. Okay, so here's this problem. The ratio of the diameters of two similar cylinders is 3 to 5. So we're definitely going to need 3 to 5. If the surface area of the smaller cylinder is 378, find the surface area of the larger cylinder. Okay, so our answer needs to be about surface area. We're given our scale factor. So in order to solve this, I need 3 squared and 5 squared, which gives me 9 to 25. So what I know with surface area is that this is 9 to 25. And they're giving me this number here, 378. And this happens to be one of the surface areas. And which one is it? It's the surface area of the smaller, or is it the surface area of the bigger one? It's the smaller. So my smaller one is on top. So this will be 378 on top. Find the surface area of the larger one. We don't know. We are going to cross multiply. 9x is equal to 378 times 25. So I'm putting it in my calculator. 378 times 25. 9x is equal to 9450. We're going to divide both sides by 9. And x is equal to 1050. So the surface area of the larger cylinder is 1050 square units. So we took all of this proportion stuff to be able to actually find the side of a cylinder without using our formula sheet. Voila, that concludes our lesson. Thank you.